So this task is from the Thinking Mathematically book, and I first came across it at CPD session from Mark actually. And it struck me because it's such a perfect example of how specialising, conjecturing, generalising and then extending can be applied to problems. And this problem works absolutely perfect for it. Because when you're first faced with it, how many squares are on a chessboard, it's quite overwhelming on an 8x8 board to figure out how many squares there are. So we're kind of forced to specialise a little bit. So if we just go down to a 1x1 board, then it's pretty obvious there's only one little square. So let's increase the size of the board now, so a 2x2 board. And now hopefully you can imagine that there's 4 1x1 squares, but then we can also make one larger 2x2 square. No patterns emerging yet, so let's continue. Let's look at a 3x3 board. And you might want to do a little sketch of a board here. Well, we can see we've got these 9 1x1 squares. How many 2x2s have we got? Well, we've got one in the top left here, one in the top right here, one in the bottom left here, and then one in the bottom right. So that's 4 2x2 squares. And then we've got this one large 3x3 square here. And at this point, I think we've specialised enough that we're ready to make a conjecture. And most pupils at this point will notice something about these numbers. If they've got any awareness of square numbers, hopefully they'll notice what's going on. And they'll make a conjecture that the 4x4 board will have 16 plus 9 plus 4 plus 1. So they'll predict that, then they can draw out the 4x4 board and they can say yes, that it's true. So now we've got this conjecture, we can then start to think about generalising. So what do we think the 8x8 board will look like? Well, the 4x4 had 16, the 3x3 had 9 to begin with, so the 8x8 board will probably start with 64 squares and then go down to 49 squares and so on, all the way down to plus 4 plus 1, where you've got that one 8x8 board at the end. And this is the total number of squares on a chessboard. So we've got this generalisation happening here. For an n by n board, it's probably going to be n squared plus n minus 1 squared plus n minus 2 squared, all the way down to 1 squared as well. Then we can extend as well, of course. At the moment we've just been looking at squares, but what if we start looking at rectangular boards, an n by m board for example. Now I've run out of time on this video, so that's one for you to have a look at, but it's just a really nice problem to highlight the 4 steps: specialise, conjecture, generalise and extending.